Let's talk about parallel lines, transversals, and angle relationships. So we'll begin with some definitions. A point is an exact location with no size, only position. We designate a point with a dot, and generally speaking, we label points with a capital letter. A line is determined by 2 points. It has no thickness and it extends forever in 2 directions. In this case, we would have line AB, or we could also call it line BA. A line segment is a subset of a line that contains 2 endpoints and all of the points between those endpoints. In this case, we have line segment EF, which could also be called line segment FE. A ray is a subset of a line as well. It contains 1 endpoint and all of the points on one side of the endpoint. In this case, we have ray DC. Notice with the notation for a ray, we designate the endpoint first, and the other letter that we use to designate the ray is just a point that is contained on the ray. If we have lines that intersect, that means they have exactly 1 point in common. So in this case, we have line EF intersecting with line EG, and they intersect at point E. If lines don't intersect, they're called parallel lines. Now, there's one more thing that has to be true, and that is that the lines have to be contained in the same plane and have no points in common. So in this case, we have line CD and line MN that are parallel. Now, if you look at the intersecting lines, you'll notice that when 2 lines intersect, they form some angles. So we're going to talk a little bit about angles and how we measure angles. You're probably used to seeing a protractor. A protractor measures angles in degrees. An acute angle would measure between 0 and 90 degrees. A right angle measures exactly 90 degrees. And if we have lines or line segments or rays which do intersect at 90-degree angles, we say that they are perpendicular to each other. An obtuse angle measures between 90 degrees and 180 degrees. And a straight angle measures exactly 180 degrees. It forms a straight line. Now, we've been talking about degrees, and when you measure an angle with a protractor, you can measure that angle to the nearest whole degree. But we actually could take that degree and subdivide it into smaller parts. If we divide a degree into 60 smaller parts, each of those parts is called a minute. Now, that may seem like a strange concept, dividing something into smaller parts, but we do it all the time. If we measure something, measure the length of something in feet, let's say, we could divide the feet into inches. So there's 12 inches in a foot. Or if we, let's say, are measuring the capacity of something and we're measuring something in gallons, maybe we divide the gallons into quarts and we say there are 4 quarts in a gallon. Well, in this case, we say that if we subdivide a degree into 60 equal parts, each of those equal parts is called a minute. Now, the minutes are very small, but a minute can also be subdivided into 60 seconds. So there are 60 seconds in 1 minute, and you'll notice the notation we have for minutes and seconds. So if 1 degree is 60 minutes and 1 minute is 60 seconds, we can use that information to convert an angle measure that's being expressed in decimal form to a form that's expressed in degrees, minutes, and seconds. Now to make it clear what's going on here, if we talk about an angle that measures 31.62 degrees, that 0.62 is actually 62 hundredths of a degree. So we're subdividing the degree into 100 equal pieces. If we want to write that angle measure in degrees, minutes, and seconds, we're going to be subdividing a degree into 60 equal parts rather than 100 equal parts, and then dividing each of the minutes also into 60 equal parts. So starting with the 31.62 degrees, 31 is a whole number, so we definitely have 31 whole degrees, and then we also have 62 hundredths of a degree. Since each degree is 60 minutes, the 62 hundredths of a degree is the same thing as 62 hundredths of 60 minutes. That means we have 31 degrees plus 37.2 minutes. Now the 37.2 minutes is not a whole number of minutes, but the 37 part of that is. So we could say we have 31 degrees, 37 minutes, and 2/10 of a minute. Each minute is 60 seconds. So we have 31 degrees, 37 minutes, and 2/10 of 60 seconds. 2/10 of 60 seconds is 12 seconds. So 31.62 degrees is the same thing as 31 degrees, 37 minutes, and 12 seconds. Now let's look at a few more definitions. Complementary angles are angles which have measures that sum to 90 degrees. So a 65-degree angle and a 25-degree angle are considered complementary. Supplementary angles have measures which sum to 180 degrees. So a 55-degree angle and a 125-degree angle are considered supplementary. When two lines intersect, they form four angles, and we can give a name to the relationship between some of the angles that are formed. Vertical angles, which are also called opposite angles, are formed when these two lines intersect. So let's just number the four angles that are formed and look at which angles are considered vertical. In this case, angles 1 and 3 would be considered vertical. They are exactly opposite each other. And angles 2 and 4 are also considered to be vertical angles. So vertical angles come in pairs. And in fact, vertical angles will always be congruent to each other. So in this particular case, we could say that angle 1 is congruent to angle 3, and angle 2 is congruent to angle 4 because we have pairs of vertical or opposite angles. A transversal is a line that intersects two other lines. So if we have these two lines and we cut through those two lines with the white line is considered the transversal. Now each time that transversal crosses a line, it creates four angles. So we actually have 8 angles that are formed by that transversal that cuts across the two lines. Now there's some special relationships between those angles that are going to be important. So we're going to give some names to the angles as they relate to each other. The interior angles are the angles that are inside the two lines that are cut by the transversal. So in this case, angles 3, 4, 5, and 6 would be called interior angles. Now we can get a little more specific with the interior angles and talk about alternate interior angles. Alternate interior angles are on opposite sides of the transversal from each other. So angle 3 and angle 5 are both interior angles, but they are considered alternate interior angles. And angle 4 and angle 6 are considered alternate interior angles. So you'll notice that alternate interior angles come in pairs. We also have some exterior angles. Exterior angles are outside of these two lines that are cut by the transversal. So in this case, that would be angle 1, angle 2, angle 7, and angle 8. We can also name the alternate exterior angles. They are exterior angles that are on opposite sides of the transversal. So in this case, angle 1 and angle 7 are alternate exterior angles, and angle 2 and angle 8 are alternate exterior angles. Notice that they come in pairs as well. Another relationship we can talk about is corresponding angles. Now with corresponding angles, we're looking at pairs of angles again. We need one angle from each of the intersections. And what has to be true about those angles is that one must be interior, one must be exterior. In this case, angle 5 is interior, angle 1 is exterior, and they have to be on the same side of the transversal. So these are both on the left side of the transversal. So angles 1 and 5 are called corresponding angles. That's not the only pair of corresponding angles in this picture. Angles 2 and 6 are corresponding. Angles 3 and 7 are also corresponding. And angles 4 and 8 are corresponding. Now we've talked about the names of these pairs of angles. There's special things that happen if we have parallel lines that are cut by a transversal. Because when you have parallel lines cut by a transversal, you have lots of pairs of angles that are congruent. So in this case, we have line M and line N that are cut by this white line that's the transversal. That creates 8 angles. We can say then that the corresponding angles in this picture must be congruent because we have parallel lines cut by the transversal. So we know that angle 1 and angle 5 are congruent, angles 2 and 6 are congruent, angles 3 and 7 are congruent, and angles 4 and 8 must be congruent because they are all corresponding angles created by crossing parallel lines with a transversal. Alternate interior angles will also be congruent. So in this case, angles 3 and 5 are congruent, and angles 4 and 6 are congruent. And alternate exterior angles will be congruent. So angles 1 and 7 are congruent, and angles 2 and 8 are congruent. Now remember, these congruencies are only happening because we have parallel lines that are cut by this transversal. Now in this case, we have 3 parallel lines that are cut by 2 transversals. The parallel lines, or parallel line segments, are segments CD, EF, and AB. And the transversals are segment CA and segment DB. We're asked to find the length of segment DF. And you'll notice we've been given the lengths of 3 of the segments in this picture. What you also need to notice is that because we have parallel lines cut by these 2 transversals, what we're seeing is 2 trapezoids that are similar to each other. This is a larger trapezoid that's similar to this smaller trapezoid. They're similar because the corresponding angles are congruent in the 2 figures. Now because they are similar trapezoids, we're going to be able to use proportions to find this missing segment length, which is segment DF. And we'll just label that with an X since we don't know how long it is. So we need to think about the ratios that we're going to use to write our proportions. So in each of these trapezoids, we're going to be able to compare a length of a bottom side of that trapezoid to the length of the right side of the trapezoid. So for the larger trapezoid on the bottom, the kind of reddish one, the bottom is 8 units long and the right side is 3.5 units long. That corresponds to those same sides in the smaller trapezoid. The bottom measures 5.6 units, and the right side, that's side DF, is unknown, so we're going to call it x. If we cross multiply to solve the proportion, we'll find out that x, which is the length of segment DF, is 2.45. Now in this case, we've also got two parallel lines, line M and line N, and we're asked to find the measures of three of the angles in the picture. We're given two of the angle measures already, and we're going to use some things that we know about congruent angles that are formed when a transversal cuts through two parallel lines in order to find these missing angle measures. So, for example, we could say that the measure of angle 3 has to be 80 degrees. The reason is that angle 3 and that 80-degree angle we've been given are vertical angles, and we know that vertical angles are always congruent. We also can say that the measure of angle 2 is 30 degrees. And that's because angle 2 and that 30-degree angle we were given are alternate interior angles. And finally, we can say that the measure of angle 1 must be 70 degrees, and the reason for that is that all the angles in a triangle will always add up to 180 degrees. All right, so here's another picture. In this case, we do not have any parallel lines, but we have been asked to find the measure of this angle x. So let's see if we can find some angle relationships to use. For example, I'm going to label this angle 1. And if I look at angle 1 and how it relates to the 120-degree angle, I can conclude that angle 1 has to measure 60 degrees. That's because that angle, which we're calling 1, and the 120-degree angle are supplementary. They form a straight angle. If I label this angle, angle 2, I know that it has to measure 50 degrees. And the reason for that is that angle 2 and that 130-degree angle also are supplementary. They form a straight angle. So now I can conclude that the measure of angle x, which is what we were asked to find, has to be 70 degrees. And that's because the measures of all the angles in this triangle have to add up to 180 degrees. So that's all there is to looking at angles and angle relationships. We'll work on some more problems in class.